Hey guys, Mr. Bouchard here, and I'm here to talk to you today about mixtures and solutions. So we're going to be able to tell the difference between compounds, mixtures, and solutions. That's our goal for this lesson. So today, first, compounds, which we discussed a little bit already. That's when two or more elements are chemically combined together, and they're bonded together. So the result of a chemical change or reaction, the smallest part of the compound is called the molecule, which we discussed also when we were talking about number of atoms. All right, so water is composed of basically the chemical compound is H2O. So there's two hydrogens plus one oxygen, and that gives you H2O. Calcium carbonate, which is the main ingredient in shells. It's calcium plus carbon plus 3 oxygens, and that makes CaCO3, all right, which makes up your calcium carbonate compounds. So basically they chemically come together and they make your full compound there. So chemical reactions make these things. And that's actually what a scallop or a clam does. They secrete that, and that's what makes their outer shell. And that's why it gets bigger over time. All right, so a compound example. Here's another one, ethyl alcohol, also known as ethanol. This is used in gasoline as an additive. And basically the chemical formula of that is C2H5OH. All right, and it's written out the way it bonds together. So basically, you have two carbon atoms, and then H is surrounded. So this is the ball and stick, and then OH. OH stays together. That's why this hydrogen is separated from the other ones. They call that an OH group. And that's usually present in alcohols. You'll see that OH group. All right, so the way you'd write out the chemical formula from this, you'd count up each of the things. So 2 C's, that's where you got that, and then 5 H's around it, so H5, and then OH, and that's what makes the chemical formula. Okay, mixtures, on the other hand, are two or more substances that are physically mixed together. All right, so this bucket of beads that you see here, that's a physical mixture of something. All right, they're not chemically combined. They exist separately. Great example of this is sand. Sand at the beach. If you pick it up and look closely at it, you'll see ground up pieces of rock. You'll also see little crystals. So these are all a mixture. All right, they do not chemically combine with each other. In mixtures, substances do not chemically combine, like I said. So a bucket of beads, sand on the beach, all right, a great example of that. Solutions, on the other hand, is when you have liquids mixing. And solutions is when the substance evenly mixes with another. So in other words, you don't see the parts of it anymore, all right? So it totally dissolves in the substance. So these dye pellets that are in this water, eventually they're just going to turn into the color water that they are. They're going to become a solution. Solvent is the part of the solution that is doing the dissolving. Most of the time, it's going to end up being water. Water tends to be the universal dissolver, as they say. Solute is the part of the solution that dissolves, so the little particles that you put in there, so like salt, water, the little salt particles dissolve in water, so salt is the solute, solvent would be water. And they make your solution, your salt water solution. Okay, solubility is also affected by certain things. So solubility is the ability of a substance to dissolve. All right, so a great example, tea. We heat up the water before we make tea. The reason why? The tea leaves will dissolve in the water more readily if it's warm. If you try to make cold tea, chances are it's going to take at least a day for the particles to dissolve and to get correctly tasting tea. So that's why we warm it up at first, for that reason. So solubility is definitely affected by temperature. So if you warm something up, it will become more soluble. If you cool it down, it will become less soluble. So hotter is faster, colder is slower. Also, we can break up the material into smaller pieces. So certain objects tend to be larger than others. Good example, sometimes you have a clump of salt in your or sugar, actually, a good example. So you're trying to dissolve sugar in something and it's clumped together. If you break it up and then stir it up, it will actually dissolve faster. So breaking it up, you'll increase its surface area and have more of it exposed, and it will be able to break down easier. And stirring also will help with that matter as well. So it takes longer to make iced tea than hot tea if you were just doing it straight from the tea bag, as an example. So just giving you that analogy. All right, lastly, sometimes we want to separate mixtures, solutions. So what can we use? So in some cases, if you're using metal objects, magnets sometimes will work to pull out materials of iron, as an example. Iron, nickel, or cobalt. Those are the three things that attract to a magnet. Filtering. So sometimes we only want certain things to go through. Good example, when you make coffee. All right, there's a coffee filter to keep the coffee grinds from going into the coffee. So you want the hot water to go through those grinds and then dissolve some of them, and then the others to stay behind. So sometimes we want to hold things from going through. So filtering is a good way to do that. And evaporation, to make salt. Naturally, they take salt water and evaporate it and leave behind the salt particles. And many of the salt companies in the world, there's some in the Mediterranean. The Mediterranean is a very salty body of water. So you'll see Mediterranean sea salt for that reason, because they tend to get salt deposits right on the beaches in that area. And then they can harvest it and clean it up and then sell it to the public. So these are ways we can separate these things, and that's something we do in basically industry and in the world. All right, so one last thing, solubility with solids and gases are a little different. So solids obviously is what I talked about earlier. So faster with higher temperature. So in case of the tea, I told you warmer water will actually break it down quicker. A larger surface area is good. You want to spread out the particles, and a lower pressure. All right, you don't want to force the particles closer together when you're dissolving a solid. Gases, on the other hand, gases are freely moving. They're all over the place. So you have to do the exact opposite to dissolve a gas. So you want lower temperatures. You want a smaller surface area. You want the particles closer together. And then lastly, you want to apply pressure on the object. So you want a higher pressure to dissolve it. So dissolving solids and gases are exactly opposite. So just know that difference, and that's pretty much it. All right, so thank you guys for tuning in, and I'll see you next time. And again, if you have any questions, feel free to email me. Thanks.